Welcome back to 8th grade Algebra 2020 edition. I know for many of you this is your first day back from spring break. Hope it was restful, and I hope you got to spend some time with the people you love the most. In any case, today we're going to be learning about quadratic geometric applications. Ooh, it's a real mouthful. So before the break, we learned about a few things that are going to come in handy today. The first is we did a classic problem where the sum was 17 and the product was 60. We wrote an equation, and then we solved those quadratic equations by setting them equal to 0. And then we learned how to factor in order to solve them. So today, we're going to be solving quadratic equations in geometric contexts. So what that means is, here we have a geometric context, meaning there's some sort of shape involved. Based on the situation, we're going to write an equation. That equation is going to turn out to be a quadratic equation. You can tell because of the squared term. And then we're going to be solving those quadratic equations and finding the solution. Here's how we're going to get there. So we're going to follow this agenda. One, we're going to go through an introduction having to do with the garden. And I'll tell you, it's the shape that we just saw. Then you're going to try it with a problem having to do with fences. And then I'm going to share some steps for success with you. From there, you're going to be doing your own practice. Many of you will be using Desmos classroom activities for the first time. It's pretty exciting. I can't wait. So let's just pause for a second to get set up for today's lesson. I want to make sure that you either have the Desmos classroom activity link or that you're ready to chat your answers to the questions in this video, and that you have a pencil and paper. Your teacher will tell you which of the first you need to do and be clear with you before we move on now. All right, so here's our first problem we're going to tackle. I'm going to read it to you. While I'm reading this, I want you to follow along and think, what is this question asking me? The garden. A rectangular garden measuring 12 meters by 16 meters is to have a walkway installed around it with a width of x meters, as shown in the diagram below, to the right. Together, the walkway and the garden have an area of 396 square meters. Write an equation that can be used to find x, the width of the walkway. Describe how your equation models the situation. Determine and state the width of the walkway in meters. So what is this question asking? Well, I'll tell you. This question is asking, what is this width x? This represents the walkway around the garden, the interior of the garden. And what do we know? Well, we know the entire area of this giant rectangle. I guess we know the area, or we could very easily find the area of this smaller rectangle of the garden on the inside, but that may or may not be useful to us. And then we really want to know x here. We want to know what x is. All right, well, here's how we're going to get there. First, this is the shape that we're talking about. Turns out the area that we know is the area of this whole rectangle. So let's now write an equation that represents the area of that rectangle. We know it's going to equal 396 square meters, but what is going to be this width here? What's this width? It's 16 plus this x over here plus this x over here. Oh, it's 16 plus 2x. Okay, so I'm going to write 16 plus 2x for the width. What about for the height? Pause, and either in the chat or in Desmos, enter the expression that represents the height of this rectangle. Go ahead. All right, so hopefully you got that the height was 12 plus 2x, or 2x plus 12. So this is 16 plus 2x, this is 12 plus 2x. And when we multiply the length by the width, or the length and the height, or the width and the height, or whatever you want to call those two dimensions, we're going to get the area, which we know is equal to 396 square meters from the problem. So now that we have this equation, what can we do? Well, if this were equal to 0, we could say that one of these factors is equal to 0, but it's not. It's equal to 396. So let's expand these terms and see what happens. So I'm going to take those terms, and I'm going to expand them and get this. 4x squared plus 56x plus 192 equals 396. Now we know we want to get the right side equal to 0. So how do we do that? We'll use inverse operations. So we subtract 396 from both sides. From there, we get 4x squared plus 56x minus 204 equals 0. I'm going to start to factor that, and you're going to finish. So I factored out of 4, and I got 4 times x squared plus 14x minus 51. I want you to take it the rest of the way and finish factoring this, and then enter your factored form either in the chat or in Desmos. Your teacher will tell you. All right, so here's what I got. I got 4 times the quantity x minus 3 times the quantity x plus 17. And we know again that that's going to equal 0 because it was equal to 0 before. It's the same thing. This is the little diagram that I used to try to figure it out. You may have done a different method. Based on that, I know that one of these factors has to be equal to 0. 4 is not equal to 0, ever. X minus 3 is equal to 0 when x is equal to 3. And x plus 17 is equal to 0 when x is equal to negative 17. So in most cases at this point, we would say we're done. We have 2 solutions, 3 or negative 17, and that's it. I don't want to hear any arguments, except here's the thing. If x is 3, then this walkway is a width of 3, which means that this whole garden plus walkway would have a width of 16 plus 3 plus 3, that's 22, and a height that's less than that, and that's fine. If the walkway is negative 17 meters wide, what does that even mean? That means it's negative 17 plus 16 plus negative 17. I don't know what a negative width for a walkway would even look like. Doesn't seem like it would work. So we say that solution actually doesn't make any sense in this context. So that's impossible. The answer is x equals 3. The walkway is 3 meters wide. Final answer. Okay, now let's review the steps that we took to solve this problem. Number 1, we read and understood the problem. We made sense of what it was asking. What do we know? What do we need to know? Number 2, we wrote an equation. In this case, we wrote an equation that represents the area, length times width, equals the area that was given. After we write that equation, we used inverse operations to set one side of the equation to 0. In this case, we subtracted 396 from both sides. Then, once we had something equal to 0, we factored it. We factored and solved for what values of x would make this 0 by making one of the terms 0. We then used context, the context of the original problem or the original situation, to eliminate any impossible answers or any answers that didn't make sense. In this case, a width of negative 17 didn't make any sense, so we eliminated it. Okay. And that's really it. You're going to use these same steps and try to apply them to a new problem in just a second. All right, now we're going to talk about fences. No, not the blockbuster movie starring Denzel Washington and Viola Davis, but rather a classic problem having to do with a partial fence on the side of a building. I know, comes up more than you would think. So here we have a problem about fences. A contractor has used 60 feet of fencing to enclose the grassy area next to a building, as pictured here. The fence encloses 400 square feet of grass. What are the dimensions of the fence? Now I want to be clear, there's no fence on the side of the building. So when you're looking for what makes up the 60 feet, none of that is going on the side of the building. Okay, you're going to do this on your own. You're going to either put your answer in the chat or you're going to answer the questions in the Desmos activity. Your teacher will tell you now. I'm going to show you the steps that you should take to solve this just in case. Welcome back. Let's see how you did. So the first thing that we wanted to do here was we wanted to understand the problem. This is talking about a fence that has 3 sides, but it's going to enclose a rectangle. We know the area and we know the sum of those 3 sides. We can use that to write 2 equations. We can write this equation for the perimeter and we can write the equation for the area. And then, since we've solved the equation for the perimeter for y, for one of the variables, we can plug that in to where it says y in the area formula and end up with a quadratic equation. You probably saw that coming since this lesson is all about solving quadratic equations. Next, we're going to try to get one side equal to 0. Here we do that by subtracting 400 from both sides. From there, because we don't want to deal with the negative, we're just going to multiply everything by -1. We're going to multiply the left side and the right side by -1. Then we set to factoring, because if we know that it's equal to 0, then if we can factor it, we can determine what makes each factor equal to 0 to find our possible solutions. So we do that. And when we do, we factor and we get 0 equals 2 times the quantity x minus 10 times the quantity x minus 20. That gives us 2 possible solutions, x equals 10 or x equals 20. Now we're not done because sometimes these solutions don't make sense in the context of the problem. So let's try it out. Well, let's see, if x is 10, then we have x, 10, 10, and 40, so y would be 40. And if x is 20, it would be 20, 20, and 20 has done it again. So we would end up with two possible solutions. Either x is 10 and y is 40, or x is 20 and y is 20. And both of those solutions make perfect sense. You can have 20 feet of fencing. Now if it's at negative 20, that's a different story. So both solutions work. So the dimensions are either 10 feet by 40 feet or 20 feet by 20 feet. End of story. All right, I hope that was helpful. You're now going to go off into practice. Your teacher's going to tell you how exactly you're going to practice today. I'm kind of excited to see what comes of this. Best of luck. I hope you do great, and I'll see you tomorrow. Bye.